looking at the last group. That's this one here. So remember, they're called noble gases. Group 0 or group 8, yeah. Noble gases. So don't be freaked out by that name. Right. They are all colorless gases at room temperature. Yeah, colorless gases at room temperature. So remember, you have helium, neon, argon, as well as the others, but these are the ones that you're going to come across: helium, neon, argon. Argon should be familiar because it's a mixture. It's part of the air mixture. Right. What differentiates these? All these have a full outer shell or electron shell. What does this mean? This means they are stable or unreactive, you can say. They are stable. They are stable or very unreactive. It's difficult to get them to react. What's the other word for that? Let's use the word inert. You're going to come across all these words. Unreactive, they are stable because they've got a full outer shell, and they are inert. So that means that you will find them as single atoms in the real world. Right. Because they are unreactive, people use noble gases in a reaction to stop other, we can say, elements or compounds reacting when you don't want them to. So for example, oxygen or water or some other compound or chemical or element in the atmosphere. So you react it in an atmosphere of noble gases, which then stops it reacting with the bits that you don't want it to react with. So it provides a inert atmosphere. Right, what we need to do is now we now need to look at the reactivity. So not the reactivity, sorry, properties. So the properties, right? The relative, they get heavier basically. The relative atomic mass increases as you go down the group. That'll be with all the groups. So this isn't anything special, but if they ask you for a property, that's what that's what it means. Right, what does this mean? There's more electrons as you go down the group. Right, let's get rid of this S. That's not a good thing to do. Go down the group. Right, because you've got more electrons, you've got more attraction to the nucleus. So that means as you go down, so as you go down group 0, the boiling point increases because, right, because you have stronger forces, that's an S, between atoms. Right, and what that will allow you to do is if they give you the boiling point of neon, you should be able to predict the boiling point of krypton. So it increasing, so we can say, right, let's get this right. Let's highlight this. Boiling point increases. Do that nicely so you can see it. Increases. The relative atomic mass increases. That's with everyone, yep. And what are they? They are all colorless gases at room temperature. They all have a full outer shell. And I think that's it. That is all you need to know for this group.